Right, next in our mission demolition game, we're going to add a follow camera. Now there are components, in particular the Cinemachine, that is a component, or a framework rather, that allows you to do this, but we're going to hand code it to learn the mechanics a little bit better. So what we want to do with this follow camera is when we launch a projectile, we want the camera to follow that projectile, and when the projectile stops moving, put the camera back in its normal position. So to start that, I'm going to select the main camera and click Add Component, New Script, and we're going to name this script Follow Cam, capital F, capital C. And then we're going to, let's see, bring that Follow Cam script up in Visual Studio. So I'm going to double click on Follow Cam, and we've got the default stubbed out Follow Cam component derived from mono behavior. So I'm going to put in some code and then come back to the video and discuss. Alright, so here are the changes to Follow Cam. We get rid of the stub method, start and update. So first we declare a static public game object, which we name capital POI for point of interest. Then another float, CamZ, which is we'll snapshot the Z position of our camera, which follow cam is attached to. And in awake, this is where we snapshot CamZ is the current position of the camera. Wherever the camera starts, that's where CamZ is. Then in fixed update, if no one has set the point of interest, meaning it's null, then we simply return and do nothing. Otherwise, we get the camera destination by first taking the position of the point of interest object and then overriding the Z position to be CamZ, and then set the position of the camera to be that destination. So every fixed update, we're going to move the camera with the point of interest. So the effect is, if we go back to our game and play it now, with these small number of changes, it won't make too much sense. So now we pull back and launch our projectile. The camera does indeed follow our projectile. You can see it real well there. But there's a bunch of issues. We're not finished yet, so I'm going to make some additional code changes, and then we're going to go through those. So the first change we'll make is making our ground much bigger. So let's see, for the textbook, we're going to make the X, set the X of our ground to be 100, but more importantly, we're going to scale this X from 100 to be 400. So that gives us a much bigger ground to play with. So next, we want to make the projectile bounce a little more, behave a little more realistically. So double click on the prefab projectile, and then we're to go into rigid body and open up these constraints. So click on that triangle. And what we want to do here is we want to freeze position Z, and we also want to freeze rotation X, Y, and Z. And we also want to add a physics material, different from the materials I'm dealing with to give color. So to create that, we go up into Project, click the plus sign, and you'll find that there's physics material here. And this guy we're going to name Phys Mat under Projectile. Then this physics material, we're going to set bounciness to 1. Let's see, anything else? Let's go back to our scene, and we're going to take that physics physics material and drop that on our projectile. So now if we double click on our projectile, we should see, if we open up our collider, we should see that physics material there. All right, so let's go back to our scene and play and see how that changed the behavior of our projectile. There. It's bounce there, and we have a longer ground. And it eventually stops. Alright. So next we're going to go back to our follow cam script and sort of improve the motion of the camera, make it smoother and constrain its movement within certain boundaries. So this is the code that we've added so far. I'm going to add a little bit more and then come back to discuss. Okay, so we introduce this easing parameter, and that's going to allow us to sort of interpolate between the current position of the camera and the next position, trying to smooth out a little bit. And then this min xy is a vector 2. So easing is set to 0.05. This min xy is set to vector 2.0. This is just constant. This will eliminate the camera from going negative in either the x or y direction. And then the way we use these is down here. Once we get our destination of the point of interest, then we set x to be the max of our min xy and the position of the point of interest, likewise y. And then we use this vector 3.lerp, this interpolation procedure, to interpolate between the current position and our new destination, passing also this easing parameter. So let's give that a try. Go back to our game. It's compiling those script changes. Play. Projectile. And you can see a little smoother. And notice the ground in it come up. So that's, oops. Let's play it one more time. Projectile. Alright, so that's fixed a few problems there. And now when the projectile stops rolling, we want to return the camera to the original position. So let's go and do that. Alright, there's a few changes in fixed update now. So notice now we initialize destination to be 0. And then we check if we have a point of interest to find. We pull the rigid body component out of that game object, point of interest, which is our projectile. And if we have a rigid body, and we call this method on the rigid body is sleeping. If it's sleeping, then basically we want to reset back to 0, so we set point of interest to be null. Next, if point of interest is still not null, then we really have the code we had before, and we set the destination to be the position of the point of interest, and then do the x and y adjustments and the easing and everything is the same as before. Okay, so now with those changes, we go back and play our game. The change should be when the projectile stops moving, the camera will come back. So the follow cam is following our projectile, bounce on the ground, comes to a halt, and we're back looking at the slingshot again. Now, if the projectile takes too long to sleep and the camera is just waiting there, then the author suggests an edit to our project settings. So we go into physics, and let's see, we need to look for sleep threshold, which is here. So we want to make that a little larger, from 0.005 to 0.01, and save that. So next, this might be the last change, we want to ensure that the ground is always in view. So to do that, oops, we want to make a change again to our FollowCam script. So back in Visual Studio, in Fixed Update, after this line setting the transform.position to be the destination, we want to type camera.main.orthographic size base orthographic size, equals destination dot y plus 10. That will force our ground to always be in sight. So let's go back and see what kind of behavior we have now with our follow cam. Alright, play the game. Interesting. You'll notice that we always saw the ground there, and now we're back to a slingshot. Okay, so that all looks good, and I think we'll close the video there and resume in the next one.